The very first thing you need to know regarding lesson 2 on this chapter is that you should review the algebraic fractions that you learned in chapter 1 or 2, I can't remember, and practicing with these exercises so that all of this becomes very simple. Apparently, this doesn't have anything to do with what I taught in lesson 1, but bear with me because this is going to be important for you to be able to expand more complex fractions, okay? So, whenever you have a fraction, just like this one over here, this can be written as this over here. If you want, go ahead and simplify this fraction, put it just as 1, and you'll see that this equals to that. But how do you go from here to here? By the way, these are called partial fractions. And whenever we transform this into that, we can do two things. This lesson or this chapter is going to focus on point 1, and then a next chapter will focus on point 2. So point 1, we can now do binomial expansions of the denominators over here. You can't over here, okay? And then this is much easier to integrate than that. More on that later, as I've said. The process of expressing complicated fractions as a sum of partial fractions, such as that, depends on the form of the denominator. So there are 3 forms that you are going to study. This is a type 1 form, in which the denominators are in this form. This is a product of expressions that are of the first type, the first order, sorry. Okay, so let's say an example. This fraction over here, okay, it is expressed as a product of two monomials that are of the first degree, okay? So what do you do to turn this into something like that? You just follow these steps. So if you have type 1, you first need to identify it as type 1. You just write it down and equal it to this. You just put A on top of the fraction with the first one and B on top of the fraction with the second one. Okay? What is the next step? You need to get rid of the denominators by multiplying both sides by the denominator of this one, the original one. What will this do? Okay? If you multiply both sides by this, you are eliminating on this side the whole denominator altogether. And then if you put this over here, this will eliminate the 1 plus x, and you are going to be left with the 2 minus x. If you do the same thing over here, this will eliminate the 2 minus x, and you are left with the 1 plus x. Okay, so right now, what are you going to have? Just this. Now, the idea is for you to figure out what the values of a and b are. So in type 1 expressions, you have 2 options. One that is the quickest and one that is more generic that you're going to use in other types. Okay? The first one, I call it the cherry picking. You cherry pick x over here so that you isolate a and b on the equation. Let's look at this. What happens if you pick x as being 2? If x is 2, this term over here is going to be eliminated. 2 minus 2 is 0, times a is 0, all right? So you end up with what? You end up with 4 plus x equals this, which is going to be 0, plus b, 1 plus 2, sorry, I meant 4 plus 2 equals a times 2 minus 2, this is going to be 0, plus b, 1 plus 2, this is going to be 3. And you have found the value of b. B is 2. Do the same thing for this term over here. If you pick x to be minus 1, what is going to happen? Here you'll have 4 minus 1 is equal to a 2 times 2 minus minus 1. So this is going to be 3. And this is going to be eliminated. So eventually you just have 3 equals 3a, which means that a is 1. You have found the value of a and b. So just plug these 2 values over there. And there you have it. What is the other method? You are going to use this later, even if you don't need it for type 1 alone. Okay? What do? Equate the coefficients. You are now at this step. Equate the coefficients and expand the brackets over here. Okay? So I just expanded this. I just expanded that. And then what do I have? I have this side over here equals to this. Now I'm going to put together like terms. So the terms with x, the terms without x, and now I compare. Okay, I'm stating that this must be equal to that. So what is the coefficient of x over here? Is 1. What is the coefficient of x over here? Is b minus a. So b minus a must be equal to 1. I do the same thing over here. The term without x is 4. Here, this term without x is just 2a plus b. So 2a plus b must be equal to 4. You have now a very simple set of simultaneous equations, and you solve them, and you should have the same result as before. B equals 2 and a equals 1. So again, you have the same result. Okay? Now, a thing that you need to pay attention to. You may have more complicated fractions that don't look like this. But you've learned in the previous chapter that you can transform them into a fraction like this. Let's take this one as an example. Okay? So the problem is that here you have x squared minus 1, but x squared minus 1 you can factorize. If you factorize x squared minus 1, you have x plus 1 times x minus 1. So you just go ahead and plug it here, and there you have it, a type 1 fraction that you can now use by using these steps to figure out the values of a, b, and in this case c, since you have 3 factors in the denominator. Let's say that you will have something like this. This doesn't look at all as type 1 fraction. So what do? You have to divide this by that, and you know how to do that. I just made here the calculation, okay? And what do you have? You have that x 6 minus x squared is going to be, where am I? X squared. Yes, you have that 6 minus x squared is going to be equal to 1 plus the remainder divided by the divisor. Yes, that's it. Okay. Then what do? Instead of writing this, you write that. And now 4 minus x squared, you can factorize it into 2 plus x, 2 minus x. So you have turned this into this, okay? And this, you can break it down into partial fractions because this is a type 1 fraction, okay? Sometimes you will have these types of fractions that on which you have to perform more calculus to transform them into a type 1 denominator, a fraction with a type 1 denominator. Let's look at type 2. Here the denominators are in the form ax plus b times cx squared plus d. Okay, as an example, I have this one over here. So what happens in this case? You divide this into partial fractions like this. Okay, you put a over this one over here, this polynomial over here, and then you put bx plus c over this one over here, the order 2 polynomial. All right, this you need to know. Okay, for all the types, you have a total of 3, don't forget. So the top one must be a polynomial of order 1, and the one in the bottom must be the polynomial of order 2. For the polynomial of order 1 that you also will have in the denominator, you just put a. For the order 2, you put bx plus c, don't forget that. Once you have this, then the procedure is more or less the same. So the first thing is, again, get rid of the denominators by multiplying both by the denominator of the main fraction. Here, I already skipped the original step, so obviously this will turn just into 2x plus 3. Doing that will eliminate the overall denominator on this side of the equation. Multiplying this by this will eliminate the x minus 1. So you are just left with the x squared plus 4. Multiplying all of this by this will eliminate the x squared plus 4, and you are left with the x minus 1. Now, in order for you to figure out the values of a and b, you'll have to use a combination of cherry picking and the second method that I taught before. So cherry picking you can only do on what? On this term over here, all right? There is no cherry picking for that one. There is no way that you can eliminate this term over here. So the value that you pick over here to eliminate this term altogether is picking x as being 1. 1 minus 1 is 0. This eliminates this whole term, okay? And if you do that, substitute here x by 1, and what you'll end up with? You'll end up with this very simple equation, and you figure out the value of a. It is 1. Now that you know the value of a, you can substitute it over here. So this will be simplified. You will just have x squared plus 4, right? And now you use the second method that involves expanding these two brackets. There you have it. And now combining like terms, here you have the term with x squared, here you have the term with x, and here the term independent of x. And now compare. Do you have any term on this side with x squared? No. So b plus 1 equals to 0. Do you have on this side any term with x? Yes, it's this one over here, coefficient 2. So the coefficient of x on this side must be equal to 2. So c minus b equals 2. What about the term without x? It's 3, must be equal to 4 minus c. So you plug this in simultaneous equations. You will have more simultaneous equations than the number of unknowns that you need to figure out. And it's just 2, b and c. You already know a. So this is going to be very easy for you to solve. And you have here the values. Now that you know the values of a, b, and c, go back to where you started and substitute a by what a is 1, b by what b is, minus 1, and c by 1. And there you have it. This is equal to that. Make sense? Type 3. The denominators are now in the form ax plus b times cx plus d squared. Okay? As an example, I'm going to use this fraction over here. What do you do in type 3? You divide this into this form. It's a over x minus 1, b times, and now pay attention, x minus 2 without a square, and then c over x minus 2 with the square. Okay? Again, don't forget these expressions for the different types. You don't have this in MF19. You need to know, you need to identify first the type of fraction, and then apply the right type in order to break it down into partial fractions, okay? The process after is the same. So it involves multiplying the whole thing by this denominator, okay? Again, on this side, it will eliminate the denominator altogether, so you are left with x plus 1. In this case, the x plus 1 is going to be eliminated, so a is going to be multiplied just by x minus 2 squared. In this case, the square over here is going to be eliminated. It is being divided by x minus 2, and you have x minus 2 times x minus 2. That's why you have the square, right? So b is going to be multiplied by x minus 1, x minus 2. And on this one is the x minus 2 squared that is going to be eliminated. You are left with the x minus 1. Again, in this case, you use a combination of cherry picking and equating coefficients. Which ones can you cherry pick? Obviously, these two. Okay? Or let's see. When x equals 1, what happens? When x equals 1, you eliminate this term because 1 minus 1 is 0, and you eliminate that term. Okay? So just go ahead, substitute x by 1, and you are left with this. So a equals 2. When x equals 2, what happens? You eliminate this term, and you eliminate this term. You are left with that one. So go ahead, substitute x by 2, and you will end up with this very simple equation, and you figure out the value of c. It's 3. Now, you still have b to calculate. There's no way for you to eliminate terms so that you can get b. So at this point, you need to expand what you have. Now that you know a and c, by the way, you substitute them over here, a and c. This will simplify the fraction, okay? And this is what you'll get here already. No, I didn't. Here I just substituted a by 2 and c by 3. Now expand the brackets, combine the like terms, and now compare. Is there any term with x squared? No, so 2 plus b equals 0. Is there any term with x? Yes, so minus 5 minus 3b equals to 1. And 5 plus 2b equals to 1. Put it over here. You have 3 equations to get one unknown, just pick one, and you get the value of b is minus 2. So a equals 2, b equals minus 2, c equals 3, substitute them over there, and you have the partial fractions for the type 3 denominators. What is the advantage of all this? How does this relate to the first lesson? We're going to see this in lesson 3. So go ahead and right now just practice with doing partial fractions. You may have questions in the exam that just ask you to do partial fractions, okay? Usually this are related to either integration, as we're going to see later, or this topic, but you may have standalone questions that just ask you to practice to do the partial fractions. So go ahead, practice, be able to identify the different types, know what expression to use for each different type, and when you're ready, go to the next lesson, because you are going to go one step further and combine this with the lesson, the contents of lesson 1.